On August 15, 1977, Ohio State University's Big Ear radio telescope picked up something strange as it swept across the sky. It was a strong, narrow-band radio signal coming from the direction of the constellation Sagittarius. Volunteer astronomer Jerry Ehman spotted the anomaly a few days later while reviewing printed data. He circled the reading in red ink and instinctively wrote "Wow" in the margin. The signal lasted exactly 72 seconds. Because the Big Ear telescope had a fixed field of view, 72 seconds was the absolute maximum amount of time it could observe any one point in the sky as the Earth rotated. Take a look at this diagram of the electromagnetic spectrum. The signal came in at exactly 1420 MHz. That is the precise frequency emitted by neutral hydrogen. Since hydrogen is the most abundant element in the universe, scientists have long reasoned that any civilization attempting interstellar communication would use this exact frequency as a universal greeting. It looked exactly like an artificial transmission, but despite decades of follow-up searches pointing telescopes at those exact coordinates, scientists have heard nothing but silence. To figure out what happened, researchers in 2025 ran over 75,000 pages of the original 1977 data through modern optical character recognition to build a searchable archive. This analysis allowed them to rule out local interference. The sun, for instance, wasn't particularly active in August 1977, making a solar flare highly unlikely. This animated diagram compares a blocky digital error with a smooth, bell-shaped Gaussian curve. The original signal matched the natural curve perfectly, confirming it was a wave rolling in from deep space, rather than a bug in the telescope software. The math removed the possibility of local interference and system glitches. The signal was a physical event that happened out in the universe. In August 2025, researchers from the University of Puerto Rico at Arecibo, led by Abel Mendez, launched a new investigation. They called their method space archaeology. Instead of pointing new telescopes at the sky, they combed through historical data archives, searching for any other narrow signals near that same 1420 MHz frequency. They actually found several. These new signals didn't originate from the Sagittarius constellation. They appeared in entirely different regions of the sky. Because these similar signals were scattered, they point to something incredibly common in interstellar space: vast clouds of neutral hydrogen gas. If multiple locations are emitting the exact same type of signal, a coordinated extraterrestrial broadcast becomes highly improbable. It suggests a naturally occurring cosmic phenomenon. That brings us to the new leading scientific explanation: the astronomical maser. A maser is a natural cosmic laser, creating a sudden, intense amplification of radio waves within a gas cloud. The theory argues this maser briefly brightened a hydrogen cloud's emission just as the Big Ear telescope swept across that exact patch of sky. This specific natural interaction accounts for both the immense power of the 1977 signal and its exact 1420 MHz frequency. No intelligent sender required. But radio astronomer Yvette Sendez, who wasn't involved in the new research, noted that while the theory has promise, the details are still pretty scant. There is a major gap in the evidence. No one has ever observed a maser operating at this specific frequency and intensity in real time. It provides a mathematically plausible mechanism for what might have happened, but it is not a confirmed explanation. The 2025 reanalysis gives us our clearest picture yet of what the WOW signal might have been, but the mystery itself remains unsolved. As Mendez points out, this decades-long process highlights how difficult it is to distinguish a genuine signal from the chaotic background noise of the cosmos. 49 years after Jerry Ehman circled those numbers in red ink, humanity's most famous candidate for extraterrestrial contact remains exactly what it was in 1977, an unexplained blip in the data, keeping our telescopes pointed at the sky.